math for game development. This topic connects math with something I'm already interested in, digital art and graphics. So it was a good fit for me. Today I will walk through what I learned, why I chose the topic, and how I changed the way I look at 3D visuals. When we look at games or 3D graphics, we usually focus on the visuals, but there's a lot of math happening behind the scenes. I wanted to understand how that math works, why it's so important, and what the textbook says about it. I also wanted to see how learning this math changed the way I view digital visuals overall. I chose this topic because I've always been into digital art and design, but I never really understood the technical side of it. I was curious about how math actually shows up in graphics and why it matters. It felt like a good mix of creativity and problem solving, and I wanted to challenge myself to learn something deeper than just the visual side. For this project, I used three main sources: 3D Primer for graphic and game development, real time 3D graphics with WebGL2, and fundamentals of computer graphics. Each book explains different parts of the math behind 3D engines, and together they gave me a full picture of how everything works. One of the first things I learned about was vectors. Vector describes direction, movement, and position in a 3D scene. They're used for things like velocity, lighting, and surface normals. Basically, vector shows up everywhere in 3D graphics, and they help objects move smoothly and realistically. The next thing was matrices. I also learned that matrices control rotation, scaling, and transition, which means they handle how objects move, turn, or change size. Every time the camera moves, matrix math is happening. Transformation can be combined or reversed, and that's a big part of how objects stay aligned in 3D space. Another thing was lighting and shading. Dot products help decide how bright a surface look, and surface normals affect shading and light highlights. Shaders use math to calculate depth, color, and lighting. This is what makes an object look realistic instead of flat. Before the project, I didn't realize how much math goes into something as simple as lighting. As you see, as the hovering balls have a shadow beneath them. The last thing was projection and cameras. Projection math is what turns a 3D scene into a 2D image on the screen. Perspective projection creates depth and distance, and cameras rely on coordinate systems and matrices to move around the scene. This helped me understand how games make things look realistic from different angles. So my reaction to all of this was honestly surprise. I knew math was involved, but I didn't know it was this central. Now, when I look at games, I can picture the calculations happening behind the scenes. It's also made math feel more useful because I can see how it connects to something I'm familiar with, like graphic design. It actually motivates me to learn more. Overall, I learned that 3D graphics heavily on rely heavily on linear algebra and geometry. Vectors, matrices, and lighting math all work together to create the visual we see. This topic helped me connect math to something I enjoy and gave me a better understanding of how 3D engines work. Also made me want to keep learning more about 3D math because it connects directly to the kind of creative work I want to do.